Hello again. This is Dr. Ron Klatz, the president and founder of the American Academy of Anti-Aging Medicine, the A4M. Today we have a very interesting individual, Jeff Bowles. Now, Jeff Bowles is not a physician, but please don't hold that against him. As a matter of fact, I think you might want to hold that for him. He is a very accomplished individual, has a background in business and forensic accounting. And this has brought him to a position where he has looked at the basic mechanisms of aging and has some very interesting insights to share with us. Jeff, if you will, please.
Oh, hi there. So, yeah, I saw your speech to the 2015 conference, A4M, and you had mentioned the singularity was coming in the year 2029. And I can tell you right now, you're very overly conservative. The singularity in finding the cause and cure for aging has just occurred already in 2021, right now. In fact, a friend of mine, Dr. Harold Katcher, has developed some Yamanaka factor orthologs from plants and mushrooms. And I will get into that later, but basically he has, together with Steve Horvath, who broke this thing wide open with his new study. They studied.
Jeff, why don't you go to this study? Because that provoked this whole interview, what you put out there about this study.
Well, I was just going to tell you that they just got the results back, and they have reversed aging in mice by 50 to 70%, depending on the tissue type.
Wow.
Reversed
it.
Okay,
let's start with that then, Jeff. Let's back up.
And then I could back into Horvath's study, but
okay.
I thought that would catch someone's attention.
That'll catch your attention. You're right. Go ahead.
Okay. All right. Yeah. So my friend Harold Katcher, there's a little group of us anti-aging theorists. We email to each other all the time. Turns out he recently, he's got a preprint in press about how he has developed some orthologs, which is just like kind of similar copies of, they do the same thing as the Yamanaka factors, which we'll get into later. And he calls this potion an elixir. And he gave these rats and mice series of injections over 2 days. And then, 2 days apart. And then they used the DNA methylation clocks that measure your age. They were developed by Steve Horvath to determine if the aging in the mouse had been reversed based on the methylation clocks. And it wasn't actually surprising. The DNA methylation age of the mice or the rats had been reversed from 50% up to 70%. And he's working on that now, and he's going to get a patent on that. And the patent is in process. So sooner or later, that protocol will be available for humans very soon.
Jeff, are the mice showing not simply increase in methylation, but are the mice actually showing a clinical reversal of aging?
Yeah. Let me see if I have that paper.
Because
title.
There's so many.
No. It's true.
I've been so many times disappointed by researchers who have shown a marker of aging being reversed. And, on paper, that's great. Unfortunately, the mice are still dying.
No, what's going on? No, they were rejuvenated in many different ways. They tested them on maze function or ability to solve a maze, and they were way better at it. Their tissues were rejuvenated. So I'll explain to you how this is all possible when you get into the other details. Did you read my blog post by any chance?
Yes, I did. Very interesting stuff.
Oh, okay. Yeah. So we can explain it, but it turns out the funny thing is, in the end, it comes down to free radicals and antioxidants. When you get all the way down to it's very complicated, this theory, But in the end, it's the free radicals and antioxidants that are causing you to age. But we can work forward to that. I don't want to work backwards from that, but it's a very simple idea.
Well, that would be incredible, because that's where all this started. The entire field of anti-aging medicine began with antioxidants.
Yeah,
theory of antioxidants and aging.
Yeah, that's it's a complicated path to get to that result, but that's the simple result in the end. So, do you want me to get in? Oh, let's talk about Horvath's study that broke this thing wide open. I had written a 1998 paper about, I had been doing a deep dive in the medical school library at Northwestern for 10 years on my own. I just kind of semi-retired, and I decided at age 30, I decided I'm going to find a cure for aging. So I just sat there and 7 days a week, 10 hours a day. And that's all I worked on. And I kind of like assembled all the relevant facts I could about aging. And it was kind of like assembling the bones of the first dinosaur, like a paleontologist. And he didn't really know how to put them together. And so I kind of put them together, and I got what looked like a dinosaur, but a few things were a little bit out of place. I didn't have all the facts to work with. And so, but this paper, I actually was at your A4M convention in Las Vegas, the first one in Las Vegas when William Shatner was supposed to show up. And I sent this to you, the abstract. And I guess it probably looked like sheer madness. And because there were so many moving parts. And I said I'd be willing to give a talk, and I didn't hear back from you. And then all of a sudden, here we are 24 years later, because everything in that paper that I predicted started being proved true, like really crazy predictions. And then in that paper, I predicted that aging was controlled by the same thing that controls development of a embryo into a blastocyst, and then into an infant, then to a child, etc. So basically, one day older is another day older. As far as aging is concerned, it's the same thing as development. So that was a prediction in my paper. And then that got me ridiculed by everybody that read the paper that was in the field of evolution. And basically, I predicted that aging was programmed. It wasn't due to accidental damage of the DNA, or there's a program that makes you older and kills you on purpose. Mm-hmm. And
that was the death hormone theory that was postulated.
That is true.
Cortisol it was.
That is
true. The researchers didn't like that very much, because that made them look bad for not finding the death hormone.
Well, the death hormone, I found it. It's actually the reproductive hormones are also the death hormones. Luteinizing hormone, follicle stimulating hormone. So I predicted in that paper they would find out, because after age 50, your LH and FSH shoots up like 500%, in both men and women, as well as human chorionic gonadotropins. And so I had read the Neuroendocrine theory of aging and disease by Ward Dean, and that was a very important book for me. And he just said, oh, it's just the reproductive system getting out of control, and he didn't see any relevance in it. I said, no, this is the death hormone. And because it goes up so much, it continues the development program. So luteinizing hormone and FSH will stimulate a child to undergo puberty and evolve into a sexually mature adult. And it also, as you get over age 50, it keeps going up, and it continues the development program to turn you into an old person that dies. So there's no real death hormone, except that reproductive hormones have a second purpose. So and then it turns out, so I predicted that luteinizing hormone would be found to be the cause of Alzheimer's disease. And they all laughed at that, of course. That's a crazy idea. And that was in 1998. I made the prediction. And then in 2005, the National Institute of Health published a paper, gonadotropins involved in neurodegenerative diseases. They found out it was true. And then oddly, someone affiliated with the editor of the journal that published my 1998 paper somehow filed a patent on the idea of using Lupron to suppress luteinizing hormone as a treatment for Alzheimer's. And I found out they got the idea out of my paper later, but that's a whole nother story. And they raised $50 million, and they called it Voyager Pharmaceuticals. And they did a phase 1 and 2 study in women with Alzheimer's. And they gave one group all those acetylcholinesterase inhibitors or whatever. And then they gave the other group the inhibitors plus Lupron. And then they measured their decline after 6 months, and the women on Lupron had stopped declining, and the women on just the inhibitors, they declined like 6 points on whatever scale it was. And they were going public with the same underwriter that took Google public, Hambrecht and Quist. They were going to raise another 100 million, and all of a sudden the study comes out about men. It didn't work in men. And I know why, but they should have asked me. I could have helped them.
No, you don't tell them. You raise 50 million yourself, and let's get the answer and make it work.
Well,
so the problem is that when these powers that be get their hands on things that work, they end up in the area. They end up in warehouse 13.
Oh, okay. But no,
so, I've seen that happen so many times. They find something that really works well, and all of a sudden it's like it's like news about the recent election. It just disappears.
Yeah. Well, big pharma doesn't like things that work, and there's no money in a cure.
Well, they're not interested in a cure. They're interested in in palliation,
chronic diseases.
Yeah, chronic disease is a good economic model.
Oh,
curing disease is a very bad economic model. So be careful.
Right. No, I've already the info's already out there. The lead scientist at Voyager Pharmaceuticals, he wasn't in on the theft of the idea. His name's Craig Atwood. He's a aging researcher at University of Wisconsin, and I told him what the problem was that declining progesterone, which protects the brain, is what causes or triggers Alzheimer's in men. And it was the increasing luteinizing hormone that triggers Alzheimer's in women. So you get this odd situation where smoking protects women from Alzheimer's, but it actually makes it more likely or worse in men, which is
that's fascinating, because that absolutely is the case.
Yeah, because
it doesn't make any direct sense.
Well,
that would happen.
The luteinizing hormone is attacking the brain of the women, and they have like 10 times more than men do their whole life. And by the time they're 90, most of them are demented. And a man who makes it to 90, he's usually sharp as a tack. And then what's causing the problem in men is the declining progesterone, which protects the brain. We have like 1/10 the progesterone of women. So, and they offset each other. So it's a very strange paradox. But so that was our discussion of the death hormone. So it does exist. It's actually the reproductive hormone. And then you got the case of those Pacific salmon that age and die in 3 days after reproduction. You look at their luteinizing hormone and FSH levels, they shoot up like 5,000%. So right after mating. So that's what's killing those fish. And it turns out, I figured out that there's two kinds of hormones. There's hormones that generate free radicals, and there's hormones that are antioxidants, like melatonin is a potent antioxidant. And so during our lives, we have a very high level of these antioxidant hormones like melatonin, DHEA, progesterone, pregnenolone, and these all go crashing down right around the age of menopause. Like melatonin drops like 90%, DHEA drops huge. That's at the same time the luteinizing hormone and FSH and HCG levels are going sky high, like 500% in humans. And so basically it's inside the cell. It's changing the antioxidant environment into more of a free radicalized environment. And so the older theory was that these free radicals are damaging the tissues and cells, and they might be, but that's not really what's driving the aging process. That those any free radical damage can be repaired. What's actually going on is free radicals are catalyzing the loss of these transcription factors that make your cell like a skin cell. It becomes a skin cell when you shut off all the other genes that are not skin cells. Genes.
Okay.
And so it turns out aging is caused by us losing these transcription factors. So our skin cell, for example, becomes less of a skin cell, and it heads towards becoming more like an embryonic stem cell. So the real cause of aging is the programmed loss of information inside all your cells. And the interesting thing, so Steve Horvath provided the last puzzle piece I needed to completely solve this Rubik's Cube. And it turns out what he found out, well, so my theory was that these hormone changes alter the free radical environment of the cell, and that leads to the loss of DNA methylation of your genes. So the gene is methylated. There's a little bump on top of it. It's a CH3. It just sits on top of the promoter area of the gene, and the gene can't be read or transcribed. So these DNA methylation bumps on your DNA, they shut off a whole bunch of different genes. And then when they're removed, the gene is turned on. So my original theory was the change in hormone levels alters the free radical redox, or the antioxidant free radical balance in the cell. And that alters the activity of these DNA methyltransferases. So when a DNA methyltransferase is in an antioxidant environment, it'll put a methyl group on the DNA. But if it's in a free radical environment, it takes it off. It works forward and reverse. And that was a prediction made in the paper too. And okay, so, and then my theory was that when you lose these DNA methylations groups, it turns on aging genes that are designed to kill you and make all these bad proteins. Well, that was a little bit big of a leap. It turns out that is true to a small extent. Mm-hmm. And Steve Horvath found about 10 genes that are that get demethylated with aging that presumably produce proteins that are bad for you and participate in your destruction. But what he did find was 36 different genes. See, now he tested the methylation patterns in more than 100 different mammalian species and 59 different tissue types. What he discovered was that the aging program driven by DNA methylation is evolved and is conserved amongst all mammalian species. So there's no doubt now that aging is programmed. So all these evolution professors are going to have to go back to the drawing board because they've got some splaining to do, because in their world it's impossible. Programmed aging is impossible because it limits the spread of your selfish genes. All right, so what Horvath found was 36 genes in all mammalian species with aging become hypermethylated. So there's all these methylations added to the promoter sites on these genes, and it shuts them down. And he found out all these 36 genes were producing transcription factors that are involved in, like, a child being developing into a teenager or a sexually mature adult. They're all development genes, and they're shutting down these development genes. So these were things that were preventing you from aging. Basically, they were producing transcription factors that go out onto your DNA and shut down all the genes, like in your skin cell, that aren't skin cell genes. And then as you get older, these genes get shut down in all mammals, and all of a sudden all your cells lose their information. Like nerve cells start to become embryonic stem cells. So you kind of lose your differentiation, and you can just look at older people. I mean, when really old people, and babies, they all kind of look alike.
That was interesting juxtaposition. You put some pictures on your article, and looking at that, I always wondered about that change in people's faces, and they say old married people start to look alike, but old people in general start to look alike.
Yeah, they all have gray hair, and it's the young adults and older kids that look much more different. So it's kind of like you kind of explain from diapers to diapers in 70 years. There you go.
Why don't you talk about the immortal jellyfish? In reading your book, one of the things I'd never thought of is age spans in various species. And then you brought up that there's a jellyfish that is immortal. Can you explain that?
Yeah, it's very interesting. So when I was working on my aging theory, I was also trying to imagine how could evolution have started with a single cell immortal photosynthetic life form and evolve into what we see today. So I'm working that Rubik's Cube of imagination of like, how did evolution, what were the steps in evolution? And then I'm working that would lead to another Rubik's Cube is like all the aging diseases we see and all the facts about aging we see currently. So I'm trying to work two Rubik's Cubes. And so one of the things I imagined was the jump from single cell life forms to multi-celled life forms. And I thought that would be a big jump in evolution. And then how would multi-cell life forms reproduce before the evolution of sex? And I figured, you know what they would do? They would just, they would reprogram every one of their cells back into an embryonic stem cell, like a spore, and completely dissolve themselves and send out like a million different single cell embryos. And that would be the best way to reproduce if you're trying to maximize the spread of your genes. So I assumed that this was something that was in our DNA, in our evolutionary path. And then you can look, it still exists in today's immortal jellyfish. So it's reproducing in this, this jellyfish, it normally ages and engages in sex, probably in a environment that's filled with predators and stuff. But when it encounters starvation or stress from the environment and not from predation, it goes into a different form of reproduction where instead of using sex, sperm, and egg cells or whatever to reproduce, it deprograms every one of the cells in its body, and it kind of dissociates itself and sends out spores everywhere, just like that reproductive system I had imagined existed in the first multi-celled organisms. And then each one of them can grow into a jellyfish. So basically it goes all the way backwards in age to zero, each one of its cells. So, and then it lives again. So if it keeps reproducing that way, it's basically immortal, but in a way it is losing all its information if it has any memories. So, but so that's why they call it immortal.
Okay. But, so we better be careful. We don't backwards program ourselves too far.
So Jeff, I have a question for you.
Okay.
From a clinical point of view, you've done all this research over how many years now? 20 years? 24 years?
35.
35 years in the library. Wow.
Oh, no. I was 10 years in the library. And then, then I got my first paper published at Medical Hypotheses. Then I still went to the library, but I don't need the library anymore. The internet's good enough.
Got it. Okay. Well, 35 years. That's significant.
Mm-hmm.
And impressive, by the way. Thank you. So what have you come across that is usable from a clinical point of view? What are you doing to forestall aging in yourself?
Well, do you want to there's one more really cool thing I have to tell you.
Okay, I'm all ears.
And we can get to the hormone things that I do for anti-aging at the end. But
we're going to have to go fast, though. We're running out of time, but go on.
Oh, this is so fascinating. All right. So in 2006, so after Horvath's paper that proves that it's programmed and all the genes involved, then I realized I have to read every abstract that has the term Yamanaka factors in it. It turns out in 2006, when they first cloned the first sheep, they basically took the DNA out of the egg and put in an adult DNA, shocked it, and it went back to time 0, and then it grew into Dolly, the cloned sheep. So then the question is, can you do that with an adult cell? Does it have to be in an egg? So there's this researcher, Yamanaka from Japan. He discovered these 4 factors that you can put into adult cells and make them turn into embryos. And then hypothetically, they could regrow into a clone, just like an egg. You don't need the egg with these Yamanaka factors. So what that's doing is taking an adult cell and reversing its age all the way back to 0 in an adult cell. So that was in 2006. I was kind of lazy. I didn't read those abstracts until after Horvath's paper this year. And so I started looking through them, and I realized how is the Yamanaka factors doing? How is it setting it going back to 0? Is it just taking these transcription factors off and it knows a shortcut to go right from an adult cell to an embryonic stem cell? And I'm going, no, I think evolution is dumb. Yamanaka factors are dumb. So it actually remembers the entire developmental path it took to get to that adult stage, and it's blind. So it takes that path all the way backwards, and so it actually re-differentiates the cell back to a young adult, and then it takes those factors off again to get it back down to 0 to a embryonic stem cell. What that means is if you can just blast cells with a brief burst of these Yamanaka factors, you can make the cells go backwards down that aging path to a younger age. And that's what happened with Harold Katcher and his mice. That's what he's doing. But you have to be careful, because there's a point of no return where it's like if you blast it for like 5 days, all of a sudden all your cells are going to turn back into embryonic stem cells. So you don't want to do that. But that is really amazing that evolution is so blind and stupid that it has to follow the exact path of development and aging in reverse to turn an adult cell back into an embryonic stem cell. But what that does is it opens it wide open for us that we can reverse aging by giving people transient blasts of Yamanaka factors or their orthologs, which is something similar. You can actually find similar factors in plants and mushrooms. That's what my friend Harold has done to reverse aging in mice by 50%. So I thought that was an interesting thing that should be on this show. No?
Yes.
God bless if it works.
It does work. They've done it already in mice. Okay.
In mice, yeah, but unfortunately, you can't always count on mice studies to translate into people studies. But
they've done it in humans. They've done it in human cells also, and it reversed the methylation clock. They haven't done it in human people. Harold's probably going to be the first one to try it.
You keep me updated with this, because I want to be patient, not number N1, but maybe N20.
David Sinclair is also doing the same experiments in, I think, mice, and he's reversed their aging, degeneration in their eyes with the Yamanaka factors. So he knows the whole thing.
Interesting. Let's jump over to the hormones, Jeff.
Okay, so bottom line is actually, so people should look at my my blog post. It's very long. You can go to jefftbowles.com. It's BOWLES, jefftbowles.com. It's the first blog post. It's got a lot of charts and graphs about the hormone changes. So basically all I do is try to reverse the hormone changes that drive the aging process. So I take 400 milligrams a night of melatonin under my tongue. Melatonin has been shown to reverse menopause in women when they're first undergoing menopause. Women can use it as birth control at 75 milligrams a night. There's studies, there was a study with Brazilian twins that One twin, they both got Alzheimer's at the same time. One twin was taking 6 milligrams of melatonin a night for sleep. The other twin was not taking anything. Within 3 years, the melatonin twin did not progress in Alzheimer's. And the one that didn't take it, he couldn't utter like 7 sounds, and he couldn't control his bowel movements. And he was just a mess. So melatonin seems to stop the progression of Alzheimer's. In fact, in the Horvath study, he found some of those genes that are affected by methylation in all mammals are involved with Alzheimer's disease. So that's probably programmed too. So I take a lot of melatonin, and that controls a bunch of other genes or other hormones. Melatonin suppresses luteinized, the bad hormones, LH and FSH. That's why women can use it for birth control. And I take 200 milligrams of pregnenolone right at night before I go to bed. That drops like 80% in most people by age 50. I take 100 milligrams of DHEA in the afternoon. That's usually when it peaks. And then lately, I've been taking much higher doses of zinc, which has a lot of antioxidant potential, magnesium, and vitamin D3. That decline, your skin makes like less than 50% of the D3 of a young person, but that's an antioxidant hormone. But it turns out these metals are also very important. I think humans have trouble absorbing magnesium and zinc when they get older, and they're probably chronically deficient. I know people taking zinc and melatonin, it helps you regrow your thymus. And they did it with rats, and Greg Fahey did it in humans. And that's your important immune system gland that makes all your T cells and keeps you from getting sick from COVID. But it turns out that humans and rats, we accumulate iron with older age. And it turns out iron is a potent free radical producer.
It's a pro-oxidant. It's the major pro-oxidant.
Yeah, huge.
Yeah, so all these metals are in part of the program to make your intracellular environment more free radicalized, and that causes your transcription factors to fall off. And
well,
then
it's interesting you mentioned that, because when they look back at people who are blood transfusion donors in Sweden, they have records that go back to 1860, and the blood transfusion the donors, the people who were regular,
they're dumping their iron. Yeah,
they dump their iron, and they have less cancer, they have less heart disease, and they may have a benefit for longevity as well.
Well, I think that's part of the aging program. You can also, Bill Sardi, have you ever heard of him?
Yeah.
Yeah, sure.
Yeah. So he's got a whole theory that iron causes aging, and I think it's correct, except it's just one part. And he suggests people take IP6, which is
a chelator.
Yeah, phytic acid or something. It's kind of like a hemoglobin without the iron in the middle.
Yep.
And it goes in, it'll take the iron out of your foods. And people that take it, their iron levels go way down if you take like 3 or 4 of these IP6 pills a day. And then, but be careful, it chelates your zinc also. So take your zinc at a different time you take your IP6. They get that out of like red yeast extract or red rice or something. A lot of plants make it. It's very common in the plant world. So yeah, you basically want to keep your, and then I also take a large amount of oral hyaluronic acid. A lot of doctors say you can't absorb it orally, but I did some research. You can absorb about 2% of it. So most of it escapes through your going to the bathroom or out of your lungs, but 10% comes out your lungs. Yeah, I was taking like huge doses of it, and I get like this weird breathing thing. Like I felt like I was inhaling carbon dioxide. I go, what the hell is going on? And I looked into it. It does escape from your lungs, but by age 40, your hyaluronic acid, it sits under your skin. It plumps out all the wrinkles. It's the clear goo that's inside your eyes. It's the clear lubricant in your joints. Doctors like to inject it into your joints to relieve pain, but you can actually absorb it orally. And it's also a potent antioxidant. It's like, you know, people use it for their skin. They rub it on their skin for wrinkles. But I found when I started taking large doses of hyaluronic acid, and I'll send you a book that I wrote but never published, because I almost killed myself with this hyaluronic acid experiment. But I'll tell you what not to do. Don't ever take 3 grams a day. But I found it after I took it, it plumped out my skin, and I used to be able to grab a bunch of skin by my ears that normally you'd cut it off for a facelift. And I can't pinch more than a ½ inch now. And it really plumped out my wrinkles at the time, makes my hair grow faster. It made my joints feel a lot better. And then, and then another thing is the recommended dose of zinc that we take, I think, is way too low. They say don't take more than 50 milligrams of elemental zinc a day or it's going to kill you. But I had experimented taking high dose D3 for many years, and I didn't realize it was inducing deficiencies in my magnesium, my zinc, my vitamin K2. I knew about K2.
I think if you take, it's important to take additional K2 if you're going to take.
Right. So the doctors think this might be interesting for you. Doctors talk about vitamin D toxicity. There's no such thing. What's actually going on? I wrote the best-selling book in the world on vitamin D, by the way. It's been translated into 10 languages. But it turns out vitamin D is completely harmless at any dose. It's just a hormone. It's a steroid hormone that controls.
Well, why do they talk about arthritis in rats, using it as rat poison?
Well,
is that misinformation?
No. Rat poison, that would be more like. Well, that's true. They're inducing deficiencies. It's the D3 is not poisoning these rats. It's suppressing their vitamin K2, and that takes all the calcium that comes that would normally be put in their bones. It goes into their blood and their soft tissues. So the D3 is causing a K2 deficiency. So that's misinformation. This D3 is not killing them. It's the K2 deficiency. And so most of the symptoms of D3 toxicity that occur after about 6 months of taking high dose D3 is caused by K2 deficiency. They're all the same symptoms, or most of them. The other symptoms that doctors call D3 toxicity are magnesium deficiency symptoms. The D3 uses up magnesium at a dramatic rate, and we're all about 80% of us are deficient to begin with. So it's not a huge number, but some people take high dose D3 and say, oh my God, I'm getting heart palpitations. I'm dizzy. I fell down the stairs. I can't sleep. I'm constipated. Blood pressure changes, and doctors think this is, hallucinations even. And doctors all call this D3 toxicity. It's actually magnesium deficiency induced by the high dose D3. And I finally found out that it ate up my zinc too, which caused an alopecia patch on the back of my hair. I thought I was taking enough zinc to counter D3 induced deficiency, because D3 uses up your zinc too. And I was taking 100 milligrams of zinc picolinate a day, and that it didn't seem to make the hair grow much faster. And I had these pains in my tendons attaching my shoulders to my arms that I thought was from weightlifting for many years, and I had stretch marks all over my arms. And I'm like, what the hell is causing this? I thought D3 was supposed to be good for you. And so now I said, you know what? I'm going to take 500 milligrams of zinc picolinate, and that's only 22% zinc by weight. So I'm taking 110 milligrams now a day of elemental zinc in 2 doses. And within 2 weeks, the pains that I'd had for years in my tendons, in my shoulders are gone, and the stretch marks have disappeared. And I looked it up. There's some doctor's got a YouTube thing. He goes, zinc symptoms of zinc deficiency, stretch marks, and hair loss. And I'm like, oh my God, I'm an idiot. But so I wrote a second book. It's high dose D3. If you take it, there's 5 cofactors you need to take with it, but so you don't damage yourself. Vitamin K2, boron, zinc, magnesium, and beta carotene. Don't take retinol because that negates a lot of the benefits of D3. But you take beta carotene, and you take the 5 cofactors with the D3, and boom, there's no such thing as vitamin D toxicity.
Well, this is all very fascinating stuff, Jeff, and we're going to have to get you back for another episode of Immortality Now to discuss some of your newest findings, even your future findings. But thank you for sharing this information with us. This is very promising stuff, and in the time of COVID depression and mass.
Well, you know, one last thing. I wrote a book that Amazon banned. It was called 16 Fascinating Spanish Flu or COVID-19 and Spanish Flu Mysteries Solved. It turns out if you can solve this, I set it up as a puzzle. Scientists love this book. And it was on Amazon for 2 weeks and they banned it. But there's 16 weird mysteries, like an Alaskan village in the Spanish flu, Egakik, Alaska, that nobody got sick when 90% of the people around them were dropping dead. And there's 16. So what nobody knew why. So there's 16 mysteries like this. And if you solve the one thing through all the mysteries, you'll understand how to prevent getting sick with COVID-19. Turns out the little village in Alaska, they all lived, 100 people lived there and worked at a salmon canning factory. Turns out salmon is super high in vitamin D3. So they're all stealing salmon in the winter and no one else is. And so this is a case of employee theft. That's why none of them got sick and they were exposed to everybody. And so if you get and it turns out, if you look at all the studies, the only people dying or getting sick from COVID are the people low in vitamin D3. They did one study in an emergency room. They tested everyone for D3 and no one over 40 was ever came in or was admitted to the hospital. So if you boost your D3 levels up enough, you don't even have to worry about COVID.
There you go.
Well, that's it for today's edition of Immortality Now from the American Academy of Anti-Aging Medicine. We're very, very happy, very pleased to speak with a researcher of the persistence and of the intellect of Jeff Bowles. And I am going to be looking at his books a lot closer now. So many years for me to get clued in, but that's what I have Carol Petersen for, because she in many ways has a better pulse on the basic research in anti-aging than anybody else I know. So thank you, Carol. Thank you, Jeff.
Thank you.
For Immortality Now, I'm Dr. Brian Klatz. God bless and be well.